If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to cover the problem number 6 to 10 of exercise 12.1 of chapter applications of trigonometry. Even before this, we have covered the first 5 problems in a separate video which was already uploaded. If you have gone through that, well and good. If not, please go through it to have a better understanding of this, because all the basics will be covered in that video. And even before we get on to this, I suggest you guys to pause the video right here even before I draw the diagram and try drawing it by yourself, so that you can check whether the diagram you have drawn and whatever I am drawing is matching. If not, if there is any confusion, or if there is anything which has been gone wrong, you could correct that as well. Alright, so let's get started. This is problem number 6. I am ready with the problem number 6 written on the board. So let us start it without any delay. Alright. So let's get started with the problem number 6. Problem number 6, it is given that suppose you are shooting an arrow from the top of a building. Okay, let me assume this is a building at a height of 6 meters. Where are you? You are at a height of 6 meters to a target on the ground. The target is on the ground. Let me join a line from foot of the tower to the target on the ground at an angle of depression of 60 degrees. So he says that an angle of depression of 60 degrees. So always remember, the angle of depression is associated, angle of elevation and angle of depression are associated with the horizontal lines. So I drew a horizontal line first and then the angle. Alright. Then what is the distance between you and the object? So let me quickly name the triangle. So where are you? You are on the top of a building. So in order to figure out the distance between you and object, this is what AC is. Alright. Here most of the people will be mistaking at this point. You are to figure out AB. No, you are not to figure out AB. You are on the top of the tower. You are not on the ground. Alright. So in order to figure out the distance between you and the target, you have to figure out AC but not AB. Alright. So here if you look at this shape, whenever we are dealing with angle of depression, the alternate angles comes into picture. Alright. We have already said that whenever we are dealing with angle of depression, alternate angles which are in the shape of Z at the corners of Z are equal, and hence angle A becomes 60 degrees. So let me write it. So given BC is equal to 6 meters, nothing but the height of the building, and what else is given? Angle of depression is given, right? Angle of depression is equal to 60 degrees, which implies angle C is equal to angle A is equal to 60 degrees. How? Since alternate angles are equal. Whenever the problem says angle of depression, we need to assume that it is something associated with the alternate angles concept. Alright. So then we are to figure out the distance from you to the object. So AC. Now that we know opposite side, we need to figure out the hypotenuse wherein the angle is known. Which trigonometric ratio can we use to figure out the opposite hypotenuse and the angle? In order to figure out the hypotenuse, I can take either sine or cosecant. So let me consider sine. From triangle ABC, sine 60 degrees is equal to BC by AC, isn't it? Opposite side by hypotenuse, nothing but BC by AC. What is sine 60 from the trigonometric table? Remember, I am just writing the values because I know how to remember the trigonometric table. If you do not know how to remember the trigonometric table, please go through the trick video which has been already uploaded. Alright. If not, I'll be attaching the trigonometry playlist in the end card. Within those videos, there is a trick video. Please go through it. Root 3 by 2 is equal to BC is 6 by AC. So if I do the cross multiplication, what happens? AC is equal to 6 into 2 by root 3, which is nothing but 12 by root 3. Okay, if I am to express in some other form, 12 can be written as 4 into root 3 into root 3. 4 3 is a 12, right? 3 itself I have written as root 3 multiplied by root 3 by root 3. Root 3 gets cancelled. AC is equal to 4 root 3. So this distance between you and the object is 4 root 3. So in this problem, many of the people will get confused for taking AB instead of AC. So that's the reason I am stressing we need to read the problem thoroughly even before we draw the diagram and understand what exactly we are to figure out from the diagram. Alright, this is about problem number 6. We are with the problem number 7. Let me read out the problem. An electrician wants to repair an electric connection on a pole of height 9 meters. Okay, there is a pole. What is the height? 9 meters. He needs to reach 1.8 meters below the top of the pole to do repair work of. Okay, the whole length of the pole is 9 meters. In order to do the repair work, he needs to go to a point which is 1.8 meters from the top. What does this become then? 9 minus 1.8 is 7.2 meters. Okay, this whole thing is 9 meters and he needs to reach a point from the top to 1.8 meters to do the repair work. Alright, what should be the length of the ladder which he should use when he climbs at an angle of 60 degrees? So here he has to do the repair work. So our ladder should be taking him to this point, not to this point, because here is where he needs to do the work, which is 1.8 meters from the top. Alright. So the ladder should take him here. Alright. When he used the ladder, he climbs at an angle of 60 degrees with the ground. Always angle of elevation or depression is associated with the horizontal line. So this guy is this ladder is making an angle of elevation of 60 degrees with the ground. Next, what will be the distance of foot of the ladder and foot of the pole? So there are two things which we need to figure out. What should be the length of the ladder is 1. Then what will be the distance between foot of the ladder and foot of the pole? One is this, the distance between foot of the ladder and foot of the pole. And the other is the hypotenuse, which is the length of the ladder. Okay, let's quickly name the triangle A, B, C, D. Alright, so coming to the solution part. Given, what did he give? Angle A is equal to, angle of elevation is equal to 60 degrees. And BD is equal to 9 meters. That is the length of the pole he gave. And CD is equal to 1.8. That is also he gave that the repair work should happen at a height from top of the building of 1.8 meters, which implied for us BC is equal to 7.2 meters. That's what we figured out for ourselves. Now, what should we figure out? What should be the length of the ladder is the first question they asked. So, in order to figure out the length of the ladder, we know the angle and the opposite side. Okay, so how do we figure out the hypotenuse? From triangle, are we aware of any ratio which uses hypotenuse and opposite side? Yes, we are. What is it? Sine. Sine 60 degrees is equal to, why are we only using sine? Why not cosecant? If you want to use cosecant, that is also well and good. No problem in that. But since that is a multiplicative inverse of this itself, I am considering sine. Alright. Sine 60 is equal to BC by what? AC. So sine 60 is what? Root 3 by 2 is equal to what is BC? 7.2 by AC. So what does AC become? AC is equal to cross multiplication. 7.2 into 2 by root 3. What is 7.2 into 2? 2 to the 4. 2 7 is 14.4 by root 3. What is this? AC, which is nothing but the length of the ladder. Okay. Next, what is the thing we need to figure out? What will be the distance between foot of the ladder and foot of the pole? AB. We know opposite, we know angle, we just need adjacent. Which one we could use? Tan. From triangle ABC, tan 60 is equal to BC by AB. Alright, BC by AB. Tan 60, what is tan 60? Root 3 is equal to BC is 7.2 by AB. If you do the cross multiplication, this is going to be 7.2 by root 3. Alright. See here I just wrote AC and AB. At the end you have to write, once you figure out AC, the length of the ladder is equal to 14.4 by root 3. AB, the distance between foot of the ladder and foot of the pole is equal to 7.2 by root 3. It is important to draw the solution into a box so that grabs the attention. That is the reason I just put boxes onto the solutions. Alright, that is about problem number 7. Let's go to problem number 8. We are with the 8th problem. A boat has to cross a river. So let me assume this is the river which is flowing. Okay, boat has to cross a river. It crosses the river by making an angle of 60 degrees with the bank of the river. So it makes an angle of 60 degrees here with the bank. Alright. Now due to stream of the water, alright, and travels a distance of 600 meters to reach the other side of the river. What is the width of the river? So what is this? This is an angle outside the triangle. So if you have a look at this, alright, again comes the alternate angles concept, and this is nothing but this, the alternate angles are equal, and here comes the 60 degrees concept. Okay, as they form the shape of Z. Okay, this is the shape of Z. So 60 degrees we have. Let me do the triangle ABC, right angle, and this is where our 60 degrees is. So in order to figure out, let me explain the diagram one more time. So a boat is crossing the river by making an angle of 60 degrees with the bank. Okay, with the bank it is making an angle of 60 degrees. And now that is because due to the stream of the water, and it travels a distance of 600 meters. So whatever the line that is drawn from this side to that side is 600 meters, and they are asking us to find the width, which is nothing but AB. Okay, initially it made an angle of 60 degrees with the bank. So here we applied the alternate angles concept and made angle C is equal to 60. Okay, we know alternate angles are equal. Alternate angles are equal, and hence this side of angle A has become angle C. Angle A is equal to angle. Okay, so angle C has become 60 degrees, which is outside of this triangle. Okay, now from here, in order to figure out the width of the river AB, it is, I am going to apply sine 60, which is opposite by hypotenuse. Okay, AB, this is root 3 by 2, and AB is something which we need to figure out. AC is 600. This is nothing but AB is equal to 600 root 3 by 2, which is nothing but 300 root 3. So this is what is the width of the river. So while drawing the diagram, be cautious. As the number increases, the problems are becoming a little complex, but try understanding this. So this is the river is what I understood it. I considered the river also as linear. This is the width of the river. So here with the bank it made an angle of 60 degrees. Using the alternate angles concept, we got angle C as 60 degrees, and in order to figure out the width, I have applied sine. Okay, that is it about the problem number 8. Let's jump into problem number 9. Yeah. So here we have the 9th problem. An observer of height 1.8 meters. An observer's height is given. But I have told you 3 important points even before getting on to applications of trigonometry. Unless and until the height of the observer or the object is specified, it is neglected. Here, the observer's height is given, hence we need to consider that. Okay, an observer of height 1.8 meters. Okay, this is 1.8 meters. Is 13.2 meters away from the palm tree. He is 13.2 meters away from the palm tree. The angle of elevation of top of the tree from his eyes, from here is 45 degrees. Angle of elevation need to have a horizontal line, right? This is 45 degrees. What is the height of the palm tree? So this is a horizontal line. Let me name this A, B, C, D and E. Okay. This is nothing but, if you consider this, it forms a rectangle. A, B, C, E. Okay. AB is 13.2 meters. In the rectangle, opposite sides are equal and hence CE also becomes 13.2. We need to figure out the height of the palm tree. Okay, let me get into the solution. So here given AE is equal to 1.8, AB is equal to 13.2, right? Here you need to write down AB is nothing but the distance between the observer and the palm tree. AE is nothing but the height of the observer, which is 1.8. Okay, from A, B, C, E, rectangle, this is a rectangle, opposite sides are equal and hence AB is equal to CE is equal to 13.2. In order to figure out the palm tree and AB is equal to CE is equal to 13.2. In the same way, AE is equal to BC is equal to 1.8. So this becomes 1.8. Now we need to find CD, which is the height of the palm tree excluding the height of the observer. Okay. In order to figure out the whole height of the palm tree, we need to include this 1.8 meters as well, which is the observer's height since it is given in this problem. Okay. First of all, we need to figure out CD. How do we figure out CD? We know the adjacent side, we know the angle. So can we do it like tan 45? Tan 45 is equal to CD by CE. CD by CE is 13.2. So CD, tan 45 is 1 from the trigonometry table, right? CD is equal to 13.2. So what is the height of the tree? Height of the tree is equal to CD plus BC, which is 13.2 plus 1.8. Nothing but 15 meters. This is BD. Okay. So the height of the observer plus the remaining height of the tree becomes the total height of the palm tree, which is 15 meters. So that is it about problem number 9. Let's jump into the next problem. We have the last problem in the exercise, which is problem number 10. In this adjacent figure, AC is equal to 6 centimeters, AB is equal to 5 centimeters and BAC is 30 degrees. Find the area of triangle. So what is the formula for area of the triangle? Half into base into height. Okay. How do we have the base as 6. What is the height? We don't know, right? If I draw a perpendicular from B to AC joining at D, does it not form a right angle triangle? Yes, it does. So BD is nothing but the height of the triangle, right? So solution given AC is 6 centimeters, AB is 5 centimeters, angle A is 30 degrees. Now we need to figure out BD. So here AC we have 6 centimeters. I draw a perpendicular such that AC got split at point D. But we don't know the distance AD and CD, right? We just know AC is equal to 6 centimeters. So I cannot go with the adjacent side because I do not know what is AD. So I have the hypotenuse and 30 degrees. So can I go with sine? Yes. So sine 30 degrees is equal to, why didn't I go with cos? Because we do not know where exactly what is the length of AD. We just know AC, but this perpendicular, how did it split, that we don't know. So I am going with sine, which is BD by AB. AB is nothing but sine 30 is 1 by 2, BD by AB is 5. If I do the cross multiplication, BD is equal to 5 by 2, which is 2.5. So what is the area of the triangle formula? Area of triangle is equal to half into base into height. What is the base? AC. Height is BD. Half into AC is 6 and BD is, we just have figured out, 2.5. 2 3s are 6. This is nothing but 3 into 2.5, 7.5 centimeters. Sorry, meter square, centimeter square this is. Okay. So area of triangle is equal to 7.5 centimeters square. So this is it about exercise 12.1 in applications of trigonometry, the chapter number 12. So this is from problem number 5 to 10. If you like the video and the content is worth sharing, then please like, share and subscribe to Anantha Lakshmi Academy. Now in the next videos, I'll be discussing the problems in next exercise 12.2. So far we have dealt with the single triangle and the distances and heights. In the exercise 12.2, we will be dealing with multiple triangles. Angle of elevations and angle of depressions on both the sides we will be dealing with. So for that, once you are familiar, you get to be familiar with the first 10 problems in exercise. You might go through the examples even before exercise 12.2, so that would be very helpful for you when we are discussing the problems in next exercise. Alright, thank you.